Webb Telescope spots sparkling crystals and life's ingredients in the Butterfly Nebula. In the heart of the Butterfly Nebula, the James Webb Space Telescope has revealed glittering crystals, fiery dust, and mysterious molecules that could explain how rocky planets like Earth first formed. Scientists found both gemstone-like silicates and smoky grains, along with life-linked carbon structures appearing in unexpected places. These discoveries not only showcase the nebula's dazzling beauty, but also shed light on the hidden chemistry that seeds stars, planets, and possibly life itself. Clues about how worlds form, clues to how planets like Earth first emerged, have been uncovered in the heart of a dazzling cosmic butterfly. Using the James Webb Space Telescope, SciTechDaily.com, Astronomy Astrophysics 101 James Webb Space Telescope. Scientists report a major step forward in understanding how the fundamental building blocks of rocky planets take shape. At the center of the Butterfly Nebula, NGC 6302, located around 3,400 light-years away in the constellation Scorpius, researchers studied cosmic dust, which consists of tiny mineral and organic particles that also contain elements tied to the origins of life. From the thick ring of dust surrounding the nebula's hidden star to the streams of material flowing outward, Webb's observations revealed new details that provide the most detailed look yet at a highly structured and energetic planetary nebula. Gemstones versus grime, the dual nature of dust. While most cosmic dust has an irregular soot-like structure, some of it arranges into striking crystalline forms that resemble microscopic gemstones. For years, scientists have debated how cosmic dust forms in space. But now, with the help of the powerful James Webb Space Telescope, we may finally have a clearer picture, said lead researcher Dr. Mikako Matsuura of Cardiff University. We were able to see both cool gemstones formed in calm, long-lasting zones and fiery grime created in violent, fast-moving parts of space, all within a single object. This discovery is a big step forward in understanding how the basic materials of planets come together. One of the hottest stars in the galaxy, the Butterfly Nebula's central star, is one of the hottest known central stars in a planetary nebula in our galaxy. With a temperature of 220,000 Kelvin, this blazing stellar engine is responsible for the nebula's gorgeous glow, but its full power may be channeled by the dense band of dusty gas that surrounds it, the torus. The new Webb data show that the torus is composed of crystalline silicates, like quartz, as well as irregularly shaped dust grains. The dust grains have sizes on the order of a millionth of a meter, large as far as cosmic dust is considered, indicating that they have been growing for a long time. Jets of iron and nickel outside the torus. The emission from different atoms and molecules takes on a multi-layered structure. The ions that require the largest amount of energy to form are concentrated close to the center, while those that require less energy are found farther from the central star. Iron and nickel are particularly interesting, tracing a pair of jets that blast outward from the star in opposite directions. Intriguingly, the team also spotted light emitted by carbon-based molecules known as polycyclic aromatic hydrocarbons, or PAHs. They form flat, ring-like structures, much like the honeycomb shapes found in beehives. On Earth, we often find PAHs in smoke from campfires, car exhaust, or burnt toast. First evidence of PAHs in oxygen-rich nebula. Given the location of the PAHs, the research team suspects that these molecules form when a bubble of wind from the central star bursts into the gas that surrounds it. This may be the first ever evidence of PAHs forming in a primary nebula, providing an important glimpse into the details of how these molecules form. NGC 6302 is one of the best-studied planetary nebulae in our galaxy and was previously imaged by the Hubble Space Telescope. https://scitechdaily.com/starsgonehaywire revealed in stunning new Hubble Space Telescope images. Planetary nebula are among the most beautiful and most elusive creatures in the cosmic zoo. These nebula form when stars with masses between about 0.8 and 8 times the mass of the Sun shed most of their mass at the end of their lives. The planetary nebula phase is fleeting, lasting only about 20,000 years. The misnamed planetary nebula, contrary to the name, planetary nebula have nothing to do with planets. The naming confusion began several hundred years ago when astronomers reported that these nebula appeared round like planets. The name stuck, even though many planetary nebulae aren't round at all. And the Butterfly Nebula is a prime example of the fantastic shapes that these nebulae can take. The Butterfly Nebula is a bipolar nebula, meaning that it has two lobes that spread in opposite directions, forming the wings of the butterfly. A dark band of dusty gas poses as the butterfly's body. This band is actually a donut-shaped torus that's being viewed from the side, hiding the nebula's central star, the ancient core of a sun-like star that energizes the nebula and causes it to glow. The dusty donut may be responsible for the nebula's insectoid shape by preventing gas from flowing outward from the star equally in all directions. Webb zooms in with unprecedented detail. The new Webb image zooms in on the center of the Butterfly Nebula and its dusty torus, providing an unprecedented view of its complex structure. The image uses data from Webb's mid-infrared instrument, MIRI, working in integral field unit mode. This mode combines a camera and a spectrograph to take images at many different wavelengths simultaneously, revealing how an object's appearance changes with wavelength. The research team supplemented the Webb observations with data from the Atacama Large Millimeter Submillimeter Array, a powerful network of radio dishes. Researchers analyzing these Webb data identified nearly 200 spectral lines, each of which holds information about the atoms and molecules in the nebula. These lines reveal nested and interconnected structures traced by different chemical species, finally pinpointing the hidden star. The research team was able to pinpoint the location of the Butterfly Nebula's central star, which heats a previously undetected dust cloud around it, making the latter shine brightly at the mid-infrared wavelengths that MIRI is sensitive to. The location of the nebula's central star has remained elusive until now, because this enshrouding dust renders it invisible at optical wavelengths. Previous searches for the star lacked the combination of infrared sensitivity and resolution necessary to spot its obscuring warm dust cloud. Reference: the JWST MIRI view of the planetary nebula NGC 6302. A UV-irradiated torus and a hot bubble triggering PAH formation by Mikako Matsura, Kevin Volk, Patrick Cavanaugh, Bruce Ballack, Roger Wesson, Albert A. Zylstra, Harriet L. Dinerstein, Els Peters, N.C. Sterling, Jan Cami, N.J. Barlow, Joel Kastner, Jeremy R. Walsh, L.B.F.M. Waters, Naomi Hirano, Isabel Alamán, Jerónimo Bernard Salas, Charmy Bott, Joris Blomer, Nicholas Clark, Olivia Jones, K. Justinot, F. Kemper, Kathleen E. Kramer, Eric Lagadek, J. Martin Lamming, F. J. Molster, Paula Moraga Baez, H. Montero, Anita M. S. Richards, Raghvendra Sahai, G. C. Sloan, Miriam Torkey, Peter A. M. Van Hoof, Nicholas J. Wright, Finbar Wilson, and Alexander Supai. 27 August 2025, Monthly Notices of the Royal Astronomical Society. DOI 1093 MNRAS, Staff 1194. https doi.org 1093 MNRAS, Staff 1194. Never miss a breakthrough. Join the SciTech Daily newsletter, scitechdaily.com/newsletter.